Okay. Okay, so here A is a is of type integer. So as long as the program exists, the data type of A will always remain an integer. And whatever value you assign to A has to be of type integer. Okay, that is what we mean by strongly typed. Okay, the data type remains the same. I cannot, in some programming language, I can declare a variable of one type and I can assign a value of a different type to it. But in Java, that is not possible. So strongly typed means data type must be assigned to every variable. And even suppose you have an expression, say 2 plus 3 into 7, even this expression will have a data type. Okay, so data types must be declared and the data type will remain constant throughout the program execution. That is what we mean when we say Java is strongly typed language. Okay, but sometimes among compatible types and sometimes even among not compatible types, we may have some conversion of one type to another type. Okay, so this is known as your type conversion. Type conversion. So this mostly occurs whenever you're doing some kind of an assignment. Like if I say int A is 5, okay, then I write something else, int B, I'm assigning A to it, okay, then this means that the value of A is copied to B, okay. So in this kind of an assignment operation, okay, there's sometimes A and B may not be of the same data type. They may be of different data types. So in that case, we have some kind of a type conversion, okay, which allows this kind of transmission to take place. So there are basically two types of conversion. So let me just write type conversion, type conversion. You have two types. One is automatic, okay, and the other is called type casting. Okay, so in automatic type conversion, what happens? This is basically conversion between compatible types. Okay, you have, this is usually between compatible types. Compatible data types. And typecasting is usually between incompatible types, certain incompatible types. Compatible types. So here first you have to understand what is the meaning of these compatible and incompatible. Now the data types that you have, that you have in Java are usually are your numeric types. And the numeric types, what are the data types that you have? Anybody? What are the numeric data types?
Integer and float, ma'am.
Integer, float, anything else? Short, long, yes. Short, long. Then double, okay. Is there anything more? Byte. So this integer, short, long, and byte, these are all whole numbers, right? So these are numeric, but these are whole numbers. So they belong to one group, whereas float and double are usually for floating point numbers. So these belongs to another category. Okay, and you must have seen in the videos that these data types have fixed sizes, okay, or fixed width. How many bits? Okay, like say byte would be 8 bits, long would be 64 bits, short would be short was how many? Short was 32. Int is 32. Okay, so like this, these data types, they have short is 16, sorry, and your long is 64, int is 32. So similarly, float and double also has their different sizes. Okay, so when we say compatible data types, so usually belonging to one category here, like integer, short, long, and byte, these are compatible. Float and double, these are compatible. Any other data types that we have in Java? Can you name any other data type?
Character.
Character, yes, char. So character is considered to be a type of numeric integer. Okay, so we can club this character along with this int, char, short, and byte. Int, short, long, and byte. Okay, because it holds characters which are either belonging to ASCII value or your Unicode value. So the value that is actually stored is some numeric value, okay, corresponding to that whichever coding is being used. Again, for this, please watch the video because I have explained it in details out there. Any other data type?
Boolean.
Pardon, I didn't hear, Vicky.
Boolean.
Boolean, yes. So Boolean is your true or false. Okay, so if a variable has a value true or false, then it is Boolean. Now, Boolean is not compatible with any of the numeric data types. Okay, it is not compatible with anything else. Okay, however, what is compatible? In short, long, byte, char, these are compatible. Float and double are compatible. Okay, but anything else is not compatible with each other. So we have to look at the compatible data types and the non-compatible data types. So let us first look at automatic type conversion. So automatic type conversion, as I have said, this takes place between two types which are compatible. So it is always between compatible types. So an example can be your long and short, int and char, these are all compatible. Float and double, these are compatible. So automatic type conversion takes place between compatible types. And there is another condition. The condition is, okay, before that, let's say I write something like this: A assigned B. Okay, this is an assignment. So here, the variable A here has a data type and B here has a data type. So B here is the data type of B is said to be the source data type, and the data type of A is called the target data type. Okay, source and target. Okay, so in order to have automatic type conversions, what you need is, first of all, A and B must be compatible, and the size of the destination, that is the target, should be larger than that of the source. Okay, so size of A must be bigger than the size of B. Okay, so target size must be larger than source size. Okay, so for automatic type conversion, both these conditions are important. So you need to satisfy both these conditions. So can you give me some examples where Which conversions will work? Anyone? I will have to give names otherwise. Please give me an example.
Ma'am, integer to byte.
Integer to byte. That means int, which will be A, or A is integer or B is integer?
A, ma'am.
In A is
Integer.
A is integer, B is byte. Yes. First of all, both are compatible. They belong to the integer numeric type. Okay. And the size of byte is 8 bits. And what is the size of integer? What will be the size of integer?
32.
How many bits? 32 bits. So it satisfies the condition, compatible, and size of the source is smaller than the size of the destination. So I can write statements like this. Int, say byte A or byte B, doesn't matter. It can give any variable name, is equal to, say, assign the value 10, and then int A, I can assign B. So the data type of B is byte and data type of A is integer. Okay, but we are making an assignment. So the value 10, which will go to variable A, is automatically, it is converted into an integer type. So this is known as your, this is your automatic type conversion. Automatic type conversion. Is this clear? Automatic, it needs two things: compatibility, and size of source must be smaller than the size of the target. So this is also known as, this kind of a conversion is also known as widening. W-I-D-E-N-I-N-G, widening. What it means? Widening means from a smaller something, you are putting it into a bigger box or bigger storage. Okay, so you are widening, you're doing a widening. Okay, so if you come across the term what is widening, it means automatic type conversion. And automatic type conversion, why it is called widening? Because from a smaller data type, you are converting it into a larger data type. So it is, you are making in basically you are widening the data type. Okay, so this is your automatic data type. Now tell automatic type conversion. Now tell me, will this be valid? Is this valid? Look at the statement and tell me, is this statement correct? B is of type integer, C is of type double. Anyone? Manikant? Vanshika? No answer? Or just look at this, whether it is okay or not. Look at the statement. Angelus, are you listening? Bante? So what is happening here? Everybody is silent. Alok? Please unmute yourself and give the answer.
Seems correct, ma'am.
This is correct. Okay, tell me, are the two types compatible, first of all?
Yes,
Ma'am, I
Uh,
guess double is decimal point and integer is not a decimal type.
Yes, so are they compatible?
No, ma'am, I guess.
So they are not compatible. Who has answered? I could not get. Is it Alok or?
Hello. Yes, ma'am.
Okay, okay, Alok. So these types are not compatible. Okay, why they are not compatible? Because one is floating point and the other is integer type. Okay, C is double, B is integer. So they are not compatible. So if they are not compatible, you cannot have automatic conversion. So this statement is wrong. Okay, let's look at another one. Suppose I give here int A byte B assign A. Is this correct?
no, ma'am.
Why is it not correct? You are correctly saying that it is not correct, but why? You can type in, you can put it in the chat box also. You can put it in the chat box also. Your voice is breaking otherwise. First of all, tell me, are they compatible? Yes, Zachariah, you are correct. It's you have said that because byte is smaller than int. Byte is smaller, byte is 8, int is 32-bit. So the target is smaller than the source. So this is not correct. This statement is not correct. But are they compatible? Byte and integer? Yes, byte and integer are compatible because they both hold integer whole values, whole numbers. Okay, so compatible. One last one. Float F 10.5 double D is assigned F here. Anyone, is this correct?
No, ma'am.
Yeah, what did you say, Vicky? Is this statement correct?
Yes, ma'am.
Yeah, the statement is correct because F is float, D is double. Both are holding that is floating point numbers. So they are compatible. Also, size of float is 32 bits. Size of double is 64 bits. So target is larger than the source. So it is compatible. Okay. So this is about automatic type conversions. Yes, Bante has also given an answer correctly, and Zachariah has also given answered correctly. Okay, so this is automatic type conversion. Okay, just remember the two things: which data types are compatible, all right, and what is the size. Okay, so this is about automatic type conversions. Automatic means I don't have to write any other statement, okay, or any other thing, and it is automatically, excuse me, automatically the type, this float type is converted into double type. Now there is also the other aspect that is called, before I go to the other one, this is also known as implicit type conversion. Okay, implicit. So many names for the same thing: implicit type conversion, automatic type conversion, okay, and widening. All of these, they mean the same thing. They have the same meaning. Okay. Next, then let us look at typecasting. So typecasting is used for conversion between non-compatible data types which are not compatible. Okay, but still it does not apply to all types of non-compatible conversions. Like say, for example, Boolean, you cannot convert it to anything else. You cannot convert it to a numeric type or a character type. Okay, so not all non-compatible types can be typecasted. Okay, so between typecasting means conversion between non-compatible, certain, let me not write all, so certain non-compatible data types. Okay, so just a second. So typecasting, like I said, this is between certain non-compatible. And here you can also have something like, which is the opposite of widening, which is narrowing. Narrowing means there is no restriction on the size. Okay, it can be from a larger data type, can be converted into a smaller data type. Like say, for example, from integer, I can convert it into a byte. I can store an integer value inside a byte. Okay, so let's see how typecasting takes place. Now for typecasting, you have a special operator. Okay, special operator. You have a special operator, and that operator is called the casting operator. So what this casting operator does is that you usually write it like this. Target type, target data type, and put the value. And then this side would be your source variable. Okay, so one example. So suppose I write int a is 10. All right. Then byte b. If I write it like this, then we have seen that this will give you an error. Okay, byte b is, first of all, a and b are compatible, yes, but byte is smaller than your, oh sorry, this is I should not have written here. This is not source, no, this is target. So byte here is byte here is smaller than integer, so that's why automatic type conversion doesn't take place. But we can still perform conversion. How? By using a casting operator like this. So instead of, if this particular statement, this will give an error. Okay, so how can we write it? We'll write it like this: byte b is assigned. Now I use this casting operator. So what is the target data type here? My target data type is byte. So I write byte here, byte a. So what we're doing, we are converting the value of, we are converting the data type of a, which was integer, explicitly into byte. Okay, and then we are assigning this value to be. Is this clear? This will convert this byte or this casting operator, that is this one, will convert integer type to byte and then assign the byte value to B. Now, here what we have done is we have used this casting operator, and because we have used this casting operator, this type of conversion is also known as your explicit conversion. Explicit conversion. Explicit again, why? Because you have to explicitly specify, okay, that convert to byte. Like here, you are explicitly specifying that convert to byte. So this typecasting is also known as your explicit conversion, or it is also known as narrowing. Narrowing again, why? Because from a larger data type integer, you are converting it into a smaller data type byte. So this is also known as narrowing. So explicit conversion, narrowing, and typecasting are the same thing. Typecasting. Okay, let's look at something more. Okay, any questions that you have here? I'm expecting some questions here in this particular example, but nobody is asking me this. Take a look at these two statements, this one and this one. Can there be some problem here?
Am I audible, ma'am?
Yeah, yes, you're audible, please.
So ma'am, like if the data types aren't compatible, then we can explicitly using narrowing, we can convert them to any data type.
Like I said here, not all data types, but certain non-compatible. Like say, for example, I cannot convert from Boolean to integer, okay, or Boolean to float, okay, because there is no
Yes, ma'am.
conversion, okay. But from byte to say floating point, I can do that. From floating point, or say from integer to floating point to integer, character to floating point, all these conversions can be performed. Boolean is a special data type which is incompatible with everything, and it also cannot be typecasted.
So ma'am, if like a char is a number, then it can be converted to floating point or something. But if the char is some alphabet, then won't it create problem?
No, then also if your char, suppose what is char? First of all, what is char? Say char C is the variable, is this. This is the character literal A. All right. So the variable C, what does it hold? Does it hold the character A, or does it hold something else?
ASCII.
ASCII value of A. It holds the ASCII value of A. And in Java, that is one again something which I had explained in the video. What is used? What code is used? Is it ASCII?
Unicode.
What code is used?
Unicode.
Unicode, exactly, Unicode. Unicode is a much larger set of characters as compared to ASCII. So that's why your ASCII has got 8 bits. Okay, ASCII is 7 plus 1, of course, for parity. Another bit is used. So this ASCII code, say in C programming, when you did, your character data type was always 8 bits. Okay, but in Java, character is 16 bits. Okay, why? Because it holds it. The characters are encoded using Unicode, and Unicode is a much larger data set or a set of characters as compared to ASCII. So even your Hindi characters, Assamese characters, all these are a part of your Unicode character set. Okay, Japanese, Korean, all these characters are there in the Unicode symbol. So your character is actually So if I say the symbol A, if it is ASCII, then the corresponding code for this is, if I am not mistaken, 97. You can always Google and find out, okay? So for every character, there is a corresponding numeric value assigned to it, okay? Whether it is ASCII or it is Unicode, okay? You can find out, you can try and find out what is the Unicode number assigned to small letter a, small a. So capital A will have a different value, okay? This say star symbol will have a different value. So every character is actually what is stored in the memory location is not the character A. Instead, it is the corresponding numeric value which is stored. Okay, so that is why it is character is compatible with the integer data types, because what is actually stored is an integer. This ASCII value or the Unicode encoding, these are all integer values. That is why character is compatible with this. So what was the question that was asked was that if you try to store, if a character is storing some character here, like say I have char C holds A, okay, then I have, okay, let me say byte B, okay, so I can do sorry, not char, I'm converting it into byte C. So now here, this is valid. Why? Because what is stored in the variable C? The Unicode character for Unicode number for small a. Okay, so this is converted into byte. Okay, and then this is stored in the variable B. So if I write if I assign a character, a specific character to the character variable, or I write C is 97. So it does not mean the character 97 is stored in C. It is whatever is the Unicode for 97. So in the Unicode character set, if you can find out what stands for, which character stands for 97, that character is stored in C. Okay. So irrespective of what is what you assign, you can, if you assign this also, first one also it's correct. If you assign this also, then also both these will work. But there is another problem here. A problem maybe which you have not been able to find out. Look at these again. Yeah.
Yes. There are certain ranges which are assigned to different data types, right?
Exactly. Yeah, right.
So if the range or the int range is bigger than the byte, so
definitely.
if we are out of the range of byte, how can we assign it to byte?
Exactly. This is what I was looking for. This was the question I was looking for. So thank you so much for asking this. That is what the problem is. That is what will happen. So just because you can convert, you can do a casting, does not mean you will always get the value same. Okay, here look at this statement. Let me use a different color. Okay, so in this statement, int a is 10. So 10, the value 10, is it within the range of byte? Is it within the range of bytes? What I mean by range, okay, each data type has so your byte is 8 bits, char is 16, short is 32. Okay, like this, you have all int and long and so on. So these different data types, they have some range, and these ranges, okay, sorry, short is 16, no? Short is 16. Short is 16. Int is 32. Okay. So they all have their ranges. How do you calculate the range? 2 to the power
-1.
-1.
2 to the power 8 or 16.
2 to the power 8.
8 -1.
Okay. So -1, 8 -1, 1 for the sign bit. So you can always get the range by using the number of bits. This is we had seen this in our DLD class also earlier. Okay, so depending upon how many bits are there for the storage, that will give you the range. So normally for your say for byte, let's say for byte, what is the range? Range is minus 128 to 127. Okay, what is the total number? 55, no? 256. 255 plus 1 for the 0, so 256. So the largest integer positive number you can represent using a byte is 256. Okay, now integer is higher than that, is it or not? Integer is 32 bits, so that the range of integer is quite high. Okay, range of integer will come to minus, it's a very large number. Okay, so when you are trying to store, in this example, when we are trying to store int a, I'm giving a value here 10, and then I'm trying to convert it, I'm trying to convert the value of a to byte, then byte is small, so you're trying to store a larger number. So if the value of a is within the range of a byte, it will be stored exactly as same. So here 10 is within the range of a byte, 256. It is less than 256. So it will allow you to store, b will have the value 10. But what happens if I have I have this int a is 257, just one more, 257, and then byte b is byte a. So what we have done, we have converted a, explicitly we have converted a to byte, and then this value I have stored. But then 257, the number 257, to store it, I need more than 8 bytes, more than 8 bits. More than 8 bits. So what actually will be stored would be this value modulo whatever is the maximum value of that data type. So in byte, the maximum value is 256. This is the largest number I can store in a byte. So the value which will be actually stored would be 257 mod or mod this, which is, what is the value? It is 1. Remainder when 256 is divided by, when 257 is divided by 256. So what will be stored here in this case? What will be the value of b? The value of b here would be 1. So what this means is that just because you can make a conversion, just because there is something called explicit typecasting, does not mean that you will always get the right value. So you have to be very careful with this when you're using explicit type conversion. Have I answered your question, Kundan?
Yes, ma'am.
Okay, you have understood this now?
Yes.
Okay, it must be within the range. If it is within the range, like our previous example here, no problem. A is 10, B will also get 10. But if it is beyond the range, in that case, A, you will get whatever is the number, whatever is the number, modulo whatever is the largest number that can be represented for that particular data type. I have explained with byte. Yeah.
In case of float and int, miss, how will it change?
In case of float and int, yeah, I'm just coming to that. That is the next thing. I'm just coming to it. So float and int. Okay. Okay. So I have, let's say, double A is say 12.5. So very small number, 12.5. And I have int B. So B is integer. Now, if I make this, is this correct? Is this correct?
No,
This will give you an error. Yeah, this will give you an error because not compatible, no automatic type conversion. So what we have to do, we have to do casting. So again, so we will write this like this. I want to convert it into int. So int is a target type A. So now what will happen? Here, what happens is A has the value 12.5, but then the moment we convert it into an integer, this integer cannot hold floating point values, the points are after the decimal point. So what will come? The statement will be valid, but what will appear in B would be only 12. Okay, so the whole part, okay, the whole part of this floating point number, only that will be transmitted to B. Only that would be stored in B, not the floating point number. So this is known as, this causes a loss of data. So this is known as truncation. Truncation. This will lead to truncation of values. Okay, again, I'm repeating this, that just because you can convert does not mean you'll always get the right value. Okay, so when you're converting between double and int, you can perform it using this statement, but there may be loss of value. If your number was say 12.0, no problem. You're only losing after decimal point, there's only 0. So no problem, you're getting the same value. But otherwise, this is what will happen. Also, one more point to be noted here is that even the whole part of it, this whole part, 12, which was there, if it is larger than the range of an integer, then also you cannot hold it. Then also that will follow the same thing of this modulo. You will have to, it will follow the same concept of this modulo for the whole part also. Okay. So this is your type casting and type conversion.
The decimal part will be dropped and the whole part will be divided, like modulus division will happen.
Modulus division will happen, but if it is within the range, no problem. If it is not within the range, then for the decimal part cut off, for the whole part, the modulo arithmetic will take place.
Okay, ma'am.
Okay.
Thank you.
All right. Just one more thing I wanted to discuss. I wanted to complete this today, actually. Okay. Okay. Now this way, we were in these examples, we were just converting from one type, one variable. We are making an assignment. One variable. So I'm using a variable here. I'm using a variable here. So there it is where the conversion takes place. But sometimes you may have expressions. Okay. So we may have automatic conversions in expressions. Okay, automatic type conversion in expressions. So let's say I have byte A is say some value 40, byte B is 30, another byte variable, byte C is 100. Okay, then I have int D is A into B plus C. Okay, now let us look at this expression. This is an expression. All right. So now what happens? A, B, C, all three are bytes. All three are data type bytes. Now, what happens here? So byte, from byte, I can easily store it in integer. That is automatic conversion will take place here. But then with when we are dealing with expressions, then we have something called promotion. promotion. Okay, so type promotion takes place in an expression. So in an expression, all these types are automatically converted into integer. Okay, so in an expression where you have, say, bytes or short, okay, these are automatically converted into, they are automatically promoted into integer. Okay, so in numeric expression, having bytes or short, automatic promotion takes place to integer. Because if you look at this, A here is 40, okay, it is within the range of bytes. B here is 30, which is within the range of bytes. But A into B is 1200. 40 is correct, 30 is also bytes, but 40 into 30 is 1200. This is beyond the range of bytes. 256 only, bytes can hold up to 256. This is bigger than that. So what happens to avoid this kind of a problem in expressions, the variables are, or the data types are automatically promoted. So this becomes int. So this 40 becomes, from byte 40, it becomes int 40. This also becomes int. So what you get, 1200, this is also int. Okay, then C, which is 100, this also becomes, this is also an integer. Then when you do plus, so 1300, this is an integer. So what is stored here is the integer. So in expressions, you have automatic type promotions. Okay, and there are certain rules for this. One more example. One more example here. Okay, like say if I just short of this, byte A 30, byte B 40. Okay, byte C is A into B. Is this correct? Will this give me an error?
Yes.
It will give me an error because what is happening? This becomes integer because it is a promotion. So this becomes integer. So integer we are trying to store in byte. So okay, automatic type conversion will not take place. What do I have to do? I have to use casting. So I will use byte A into B. But still here, result is 1200. 1200 is beyond the range. So you'll have 1200 modulo 256. Okay, so this is the value which will be stored in the variable C. All right, so this is about integers in expressions. Now this is true for these rules are true. Automatic type promotion rules are true for all types. Okay, so if, let me just put down the rules for automatic type promotion. What is the first rule? The first rule is if an expression has byte, char, short, okay, if you have an expression of all these, then everything is promoted to integer. Okay, then if you have at least one long type in your expression, then it is converted to, automatically promoted to long. Okay, if there is at least one float, okay, then it is automatically converted to float. And number 4, if there is at least one double, then it is, the whole expression is promoted to double. So these are the rules of your type promotion in an expression. So if I have a variable, something like this, please try to find this out. I have byte B is 42, char C is A, short S is 1024, int I is 5000. All of these are within the range. Float F is 5.67. F, again, if you have watched the video, you will understand why I'm putting this F here. I will not explain. If you have seen the video, you will know this. Otherwise, please go and watch the video. So double D is 0.1234. Okay, this is an example which is there in the book. Okay, now I have this statement. Double result is F into B plus I divided by C minus D into S. Okay, so let's see how this will execute. Let's see how this will execute. So F into B. So first, this is the expression. I will just write it separately here. F into B plus I divided by C minus D into S. Okay, so it follows the precedence of the operators and the associativity. So first, this will execute. So what is the type of F? F is float and B is byte. Okay, so what will be the resultant type? What will be the type of this F into B? What will be the type? Look at the rules. If there is at least one float in the expression, the entire expression becomes a float. So there is one float here. This is float. This is byte. So this becomes what? Float. Then look at this part. I and C. I is integer, C is character. So integer, character, if there is a character and an integer, it is promoted to integer. D and S, D is double, S is short. So if there is a double and a short, it gets promoted to double. Okay. Now we will evaluate the rest of it. So we have the types of this. Now we get the second round. In the second round, we evaluate this F into B plus I divided by C. So I have float and int. So what will be the type of this expression? What will be the type?
Float, ma'am.
Float, it will be float. Okay. Then I will evaluate the bigger last, that is this part minus this part. So I have float and double. So what would be the result?
Double.
Result would be of type double. All right. So you can put the values, and see how it works out. All right. You can work this problem out and see what would be the result. Okay, because there might be some truncations and so on. So I would want you to write this code and then just test it out. Just print the value of result. Okay. So any questions now? That's all I have for the class today. Now, if you have any questions, you can ask here.
Ma'am, the double variable should have a suffix D.
No, by default, when you give a number, it is by default, it is D. Okay. If you want to explicitly give it as D, if you give a D also, it is not a problem. You can give it as a D out here. But by default, it is double. But for float, okay, if I simply say the literal 5.67, then 5.67 by default is double. Okay. If you want it to explicitly mean a float, then you have to add the suffix f to it. The same goes for your long, short, all these also. So default is integer. Any other questions you have?
No, ma'am.
Okay, so I hope this is clear. This type conversions, this is very important because many a times you'll find that you are not getting the result. You may be doing everything correctly. Your logic in your program is correct, but then you're not getting your result. So the problem could lie in this type of conversions, these automatic conversions. Okay, sometimes some points, something may be truncated, something may be you may lose data because of the narrowing. Okay, because of the modulo. So you have to be careful, and you have to be aware that these are the things which can happen. Okay, and also this type of questions, a lot of questions comes in multiple choice MCQs and all that, when if you go for interviews and all later on. So it is good to be clear on these. Okay. And let me stop the share. Okay, so now I think have you all installed your systems? Are you having some problem with the installations or anything? In fact, you can even I would suggest that you install it and install Java and work with it. Okay, but in case you do not have a laptop or something, then you can also try out. There are several websites which gives you the interface for running your Java programs. Okay, so for small programs, you can just type in your code there and then execute it in the website itself. So you can just look for some websites. So online Java execution, you can just search for that, and you can try it out there. Okay. So if there are no more questions here, then I will close the meeting for today. And again, I'm saying, please see the videos that are there in that I have put up. Okay. Or if you want, see, I'm not saying that I'm not going to tell you that to restrict yourself to only the videos that I have made. The internet is full of good tutorials on Java. There are very good books. So you can read the books, you can watch the tutorials, but keep yourself up to date, because in between, like I'm going to take some live classes like this. For that, to understand what goes on in these classes, you have to understand what has been taught already. Okay, so keep yourself abreast of what topics have already been uploaded. Okay, and soon I'll give you some worksheets so that we can start our practical works also. So that is all from my side. Anything that you want to say? Anything from your side? What do you feel about these live classes? First of, tell me this. I would like to get some feedback. Do you think we need this, or only put videos, recorded videos?
No, ma'am, this is better.
Yes, ma'am. Live classes are better.
What about the rest? I'm not hearing anything from the rest of the students. Nikhil? They have just switched on the class and gone for other works. Mardandar, are you there? Okay, so our
Live
class-
classes are better.
Okay, Jasanpreet. Okay, I will continue taking live classes, but then some topics I will have to give you as recorded, because many people, they have also given asked for like that they may not be able to attend the full class, all of these. So I will try to keep as many live classes as possible. Okay, so okay, then I have seen some in the chat box also. Some of you have said live classes are better. Yeah, even me, I prefer taking live classes. No, otherwise, I don't know whether you have looked at the videos or not. I don't know whether you have understood or not. So it is better for me, these live classes also. So okay, then we will continue with these live classes as much as I can. Okay, so I would also like you to put effort from your side. Okay, so that's all then. Thank you, everyone.
Thank you, ma'am.
And thank you for attending, and have a nice day. Bye bye.
Thank you, ma'am.
Thank you, ma'am.